Ladies and gentlemen, a very warm welcome indeed to our seminar this afternoon, Innovation in Aerospace. Some time back, in the early months of my presidency here, we embarked on a series of innovation in different sectors. We've covered to date construction, innovation in business systems, materials, energy systems, medical engineering, the auto industry, and today, aerospace. So we're very grateful this afternoon to all our speakers and guests for making time for this event. I'm sorry that the Queen's speech has held some people up, but I guess the majority have now come in, so we're intending to make a start. I also want to particularly thank the Royal Aeronautical Society, who are supporting this event with us today. Now, the UK has a strong record of engineering innovation, and as the National Academy for Engineering, much of our work is focused on supporting and promoting innovation. We give prizes and awards for great innovation, including the Queen Elizabeth Prize, the £1 million prize every second year, which is our major international award. And then at home, the McRoberts Award, which is the UK's top innovation prize. Rolls-Royce, who we will hear from later today, have been shortlisted for this year's 2014 McRobert Prize final for their lift system, powering the world's first supersonic vertical takeoff jet. The UK's aerospace sector contributes around 24 billion a year to the economy, with high growth potential in the coming years ahead. And this is clearly driven by a global increase in air traffic, which is predicted to rise at around 4.7% a year between now and 2030, meaning a doubling in air traffic over the next 15 years. Now, aerospace is one of the great jewels in the crown of the UK's advanced manufacturing sector. The UK designs, manufactures, assembles some of the most technologically complex and valuable parts of today's airliners, including the wings, engines, and advanced aircraft systems. We are also one of only a handful of nations with the capability to design and manufacture advanced helicopters. The UK has the #1 aerospace industry supply base in Europe, and globally we're second only to the United States. The sector alone supports more than 3,000 companies, 100,000 people in direct jobs, supporting an additional 130,000 jobs indirectly. So we're talking about an extremely important sector, and we'll hear a lot more about that from our first speaker. So pressure from airlines to reduce operating costs, combined with the need to reduce aviation's environmental impact, means that new aircraft need to be highly innovative. The ability of UK industry to develop and apply these technologies will be crucial to the future of the sector. And the Aerospace Growth Partnership, which we'll hear more about from our first speaker, is the strategic partnership between government and industry established to secure the future of the UK aerospace industry for the next 20 years and beyond. And that's part of the nation's modern industrial strategy, which we as an academy have certainly promoted rather strongly. The Growth Partnership was established as a vehicle to tackle barriers to growth, boost exports, and grow the number of high-value jobs in the UK. It's already embarked on several initiatives, the establishment of the Aerospace Technology Institute, representing a joint investment from government and industry. Secondly, it has established £40 million National Aerospace Technology Exploitation Programme aimed at supply chain companies. And thirdly, it has established a scheme to award aerospace MSc bursaries with the aim of creating more master-level qualified engineering professionals to work in the UK aerospace industry. So this Academy and the Royal Aeronautical Society are delivering this programme, which has awarded already the first 100 bursaries, with 19 of them, thankfully, awarded to women. Today, Our terrific lineup of speakers represents a range of industries and organisations working right across the aerospace sector, and they will share with us pioneering technologies, inventive processes, and novel operating systems. Each of the speakers will have 20 minutes to speak, and after a session involving 3 or so, we will then have a Q&A session, and you can save your questions up to that. So each speaker will speak for 20 minutes, and we hope we can keep to time, otherwise I'll jump up and down. But our first speaker is Paul Everitt, the Chief Executive of the ADS Group. And Paul, he's our first speaker, and Paul has had more than 20 years' experience of the manufacturing and transport sectors. And he's CEO of ADS, the trade organisation advancing the UK aerospace, defence, security and space industries. And as a member of the Aerospace Growth Partnership, he's ideally placed to give us with an overview of the partnership's work and the modern industrial strategy being developed to support this sector. And this will provide us, I believe, with an excellent context for the proceedings for the rest of the afternoon. So Paul, very delighted to have you here.
Good afternoon, and well, thank you very much for inviting me along. Get rid of that. Particularly, say a good recognition of the work that the Academy does and the Royal and Aeronautical Society, who are key parts of the landscape in which we as a sector operate. I thought I'd sort of touch upon 3 things really this afternoon in my 20 minutes. One is a little bit about the sort of political context and background to industrial strategy, a little bit more detail about what some of the things that are going on within the Aerospace Growth Partnership, and then a shameless plug for the Farnborough International Air Show, which is always important, but also some things about how that might fit in with our overall quest to make UK manufacturing and engineering that bit more popular. So we live in a fantastic time, having spent probably the last 30 or 40 years working with governments who effectively said the only role for government was to get out of the way of business. We arrive at a set of circumstances where government believes there is a role for industry and government to work together. That's an unusual set of circumstances. I guess we go back to the financial crisis and the recession. One of the good things that emerged from that was a recognition across our kind of political establishment that designing, developing, manufacturing things that you can sell around the world is actually a good thing. And the concept of rebalancing our economy, so less emphasis on financial services, more emphasis on manufacturing and engineering is a good thing. Rebalancing also in terms of economic activity around our country. So, as important as a London resident, the success of London and the South East as an economy is, it has to be alongside success in other parts of our country. And I think there is a recognition that that is an important thing, and the sorts of sectors like aerospace, like automotive, like others, have the power to provide good value jobs for the long term in all parts of the country. And if we go back, due credit to Peter Mandelson, his phrases were about industrial activism around 2008, 2009. Unusually, certainly in the political world, Vince Cable and as then Mark Prisk, as part of the coalition, now Vince Cable and Michael Fallon, have really taken that forward. There hasn't been, if you like, a big change, everyone stopping to wonder what they were going to do. Actually, we've seen the further development of industrial strategy. And this isn't a reversion to what we might see as 60s, 70s corporate planning, or governments seeking to support large organisations or what they would then see as industries too big to fail. This is government recognising that there is a legitimate role to play, helping and supporting successful sectors win more and better business in markets around the world. And that's, I think, something that we should all encourage and support. And the heart of these industrial strategies, certainly those that have been so far successful, is about genuine partnership and collaboration. I've been fortunate to be involved in, the Aerospace Growth Partnership, before that a little in the automotive equivalent, and as much of the benefit has come from industry itself working together and finding an appropriate place for collaboration and joint working as it has been industry and government. And I think the kind of key sort of light for many of industrialists was there was a way in which working together they improved the political, economic, financial climate in the UK to the betterment of their own business. So particularly for those who've got, if you like, international boards, making the UK a better and more attractive place for investment, had no negative impact in terms of the competition that they might have with other companies in the sector, but it did make the UK, their bit of the business, more likely to win investment in the UK. So I'd say that this whole question of collaboration is really important, and I might come back a little bit to that. I think the other thing that's been really important, and where these strategies have been successful, is that industry has stepped up. This isn't a question that industry comes together, it gives the government a bit of a laundry list of all the things it wants, and then the government goes away and sort of sees which ones it can do. This is actually working together, but also spending together. And I'll come on to examples in the aerospace sector where the UK-based industry has made big commitments and is sort of shouldering its share of the burden in investment into the UK alongside the contribution that government is making. So I think as we look forward, what's important? What's important is now we have political durability. These industrial strategies are changing the way the international community sees the UK, not just in aerospace, but we've now got a number of these strategies that are operational. That begins to change the way in which people perceive the UK. We have lots of international governments looking at what the UK is doing and trying to work out how they might be able to replicate it where they are. But for me, the big challenge will be after the next election, irrespective of the outcome, that there is not a pause, that we continue with the relationships, the direction of the strategies, and that we keep implementing, because that will be the most significant development that we could possibly demonstrate to the international community, and particularly the international business community. Certainty and kind of a collaborative working environment that spreads across different political timescales. So to me, that's going to be really important. Clearly, we have a number of elections, or certainly referenda, coming up over the next 2 or 3 years. We have an issue up in Scotland, we have a general election, and then we may or may not, depending on the outcome of the general election, have something around the EU. From an industry point of view, I guess we pick our words carefully, but we stand back and go, it's a tough job selling the UK, but we should try not to make it more difficult. Decisions will be made by the people in Scotland. We've certainly made the point, I've made the point that their decisions need to be based on the broader economic and industrial implications of any change, and we hope that that kind of plays into the decision-making process. And similarly, from an international and global business perspective, the UK being a strong and active participant within the EU is incredibly important. And again, I think that I've resolved, obviously, on every occasion to at least mention it, because I think it is important, and too many people get the opportunity to say bad things. Occasionally, we might disagree with a lot of the regulation or the way in which regulation is implemented at an EU level, but we also see huge benefit and advantage, and that needs to be put out there. So, if we now look at the Aerospace Growth Partnership, the background to this and why Peter Mandelson and then Vince Cable were convinced is because the scale of the global opportunity is so vast that to miss it would be a crime of enormous proportion. John mentioned a few facts and figures. We have a global market that over the next 20 years is going to be worth something like $4.5 trillion. And currently, the UK has about 16 or 17% of that. So, growth is going to happen. Forecast for large aircraft, 29,000, we expect to deliver something like that over the next 20 years, perhaps 40,000 helicopters, quite a large number of business jets. Details on helicopters and business jets are a little bit more difficult to quantify, but we've got better numbers around large aircraft, so that's 100 seats and above, the sort of thing that Boeing and Airbus do. And we have a big slice of that market. And so if we think about it, this is 29,000 new aircraft. That's a lot. How do we know that's going to be delivered? Today, as an industry, we have a confirmed order book of 11,000, just over 11,000 large aircraft. So we've got 8 or 9, at current delivery rates, 8 or 9 years' worth of future work. And most of the two major players in the market are increasing the rates at which they deliver. So we've seen the rates at which large aircraft are being delivered double in the course of the last 10 years. And over the last, certainly data I've got, 2 to 3 years, is we're increasing that delivery rate by 6 or 7% per annum in order to try and reduce the backlog. Now that's a huge, huge market opportunity, and we are seeing, if you're in the aerospace industry and the aerospace supply chain here in the UK, the pressure that you are under is actually being able to meet the capacity and capability requirements of your customer. That's a challenging environment, but a much better one, if you like, than not having a business to chase. So it's a big opportunity, and what are we doing in order to ensure that we are, firstly, protecting what we've got, but then positioning ourselves for what comes forth over the next 20 or 30 years. And there's no real there's fairly consensus on, in most strategies that you look at, the challenges are the same. It's about the skills of our people. Do we have enough of the right skilled people? Are they available to us in the right quantity at the right time? Do we have the base of technology and innovation to position ourselves not just for what's being delivered now, but what will be required in the next 10, 20 years? It's about ensuring that we have a supply chain that is strong and robust and can meet the productivity and competitiveness challenge that's going forward, because whilst the volumes are growing, I have to say the end customer, that's to say airlines up and down or across the globe, are not getting any richer. If anything, that too is a competitive, incredibly competitive marketplace, and at least one of the reasons why we are seeing sustained growth in passenger demand around the world is because in real terms the cost of travel is going down. Now, for airlines, that means they cannot afford, if you like, to keep buying expensive products at the same price as they've always bought them. They want products that are cleaner, more efficient, more environmentally friendly, and cheaper. For those of us who are familiar with the car industry, it's a familiar tale. But that puts pressure on everybody, but particularly the supply chain. So the AGP is a genuine partnership headed by Michael Fallon and Marcus Bryson. Marcus, in addition to being my boss, is the CEO for GK and Aerospace. We've got probably about 10 or 12 companies and leaders who are involved in that kind of senior level board, and then probably something like 80 or 90 businesses, 200-300 individuals who are regularly engaged in the various work streams that the AGP is working on. So we have, not surprisingly, groups looking at skills, technology, manufacturing technology, not to be forgotten, the supply chain, and what we might see as broader engagement. I want to focus on a couple of specifics. So firstly is around technology. As John mentioned, we have now established an Aerospace Technology Institute. The Institute is orchestrating the record, unprecedented, £2 billion collaborative investment that's been made, will be being made over the next now 6 years. Billion from industry, billion from government. And what's amazing, if you like, in terms of the forward look is the programme lasts till beyond not just the next election, but the election after that. And that's an unprecedented level of forward commitment and confidence, both from government, but also to industry in what we can achieve in the UK. The aim of the Institute is to invest into those areas of technology which are UK strengths and which will, if you like, be key in determining what future products look like. So you'll be not surprised, it's around wings, it's around propulsion systems, it's around advanced systems, so the electronics and electronic systems that run in and out and around an aircraft, and the aero structures that help create and form it. And again, the really important thing is the AGP has been up and running probably about 3 years, so from its inception to where we are now. We got the big go-ahead from government around the ATI probably 12 months ago. So we did sort of 2 years of hard work getting to a strategy, getting that agreed, understanding what we were going to do, and we've been in effectively delivery mode. So around the ATI, we have it is established. We haven't waited for all of the details to be worked out, so programs are already being approved and run, albeit not exactly through the ATI, but around what we've been doing. I'm guessing there's a forward commitment to work over the next 2-3 years, probably already around 450 towards 500 million, again, collaborative funding. So these are a combination of big programs with big companies and then kind of smaller scale operations run through, if you like, the back office is the technology strategy board, so many of the calls that they use are being supplemented by specific aerospace technology calls, so works very, very, very well. The other part of the ATI, in addition to managing the program, is about engaging, particularly at a European level, to ensure that the UK does more to engage with some of those European programs and get the benefit into the UK of some of the funding and sourcing available. But it's also about the ATI being the engagement point with many of the other international organisations out there, not just in Europe but in other parts of the world. Because part of the strategy that we have is we're great. Our biggest customer from a UK perspective, Rolls-Royce, Airbus. But there are other providers out there. We could be doing more work with Boeing, and we could certainly do more work with people like Embraer from Brazil, Bombardier we do work with, but perhaps we could do more. And also there are new entrants, so particularly in China, but in other parts of the world, people want an aerospace industry. We can be the supplier of choice. We have some preferred customers, clearly, but we should position ourselves to ensure that we are able to grow our industry in these other places as well. John also mentioned the bursary scheme. So again, I'd like to thank the two organisations who are helping to facilitate that. Again, from a standing start, 100 graduates will be getting their awards this June or July. I'm hoping a couple of hundred more will start come September, October. So this is real and tangible. And I think this is it's really important to understand that there are lots of things that governments do which they announce and announce and announce again. But in this circumstances, these are real things being delivered on the ground, so to speak, that will make a real and tangible difference to our industry, not just in the short term, but the short and long term. And finally, I also mentioned the NATEP scheme, so that's the National Aerospace Technology Exploitation Programme. This is specifically focused on the supply chain and smaller companies. This is a limited amount of funding, but it's about 40 million, again, collaborative, from industry and from government, focused to give companies that have not traditionally done R&D or product innovation, product development, some money and, more importantly, sort of mentoring support so that they can begin to put in place the processes and the systems that will help them in some specific cases which are being funded, but also embed within that supply chain the ability to contribute more, to generate their own innovation, and thereby not only strengthen their own business, but be a better supplier for the global aerospace providers. There are more challenges ahead. As I say, the supply chain is particularly important, and ensuring that we have a strong and robust supply chain in the UK. So we are doing work on trying to create programs that help and support the supply chain. There is already one up and running, which is called Sharing in Growth, originally developed by Rolls-Royce effectively, but is actually available to the whole of the aerospace supply chain, and we're looking at how we might advance that, because being competitive is part of the whole process we are trying to manage. So this is a tremendously successful partnership with government, and one that we hope and strongly are committed to for the longer term. One of the areas in which we're going to demonstrate some of that will be between July the 14th and 20th down at Farnborough International Air Show. It is genuinely a global event, one of the few that the UK still has, so please come along, it will be great. Importantly, we are going to use it as a platform to demonstrate what's being done within the Aerospace Growth Partnership. Two specific areas for us which are important. One is we have, as they do on any exhibition, we have an innovation zone. The innovation zone, though, is populated by UK universities, the Technology Strategy Board, our new Aerospace Technology Institute, the new, well, not so new now, but the High Value Manufacturing Catapult and its various outlets. And the idea very much is to demonstrate to the rest of the world exactly what we're doing in the UK, but also, because there's an awful lot of UK businesses that will be at the show, hopefully engage more of those companies in the support that's actually available to them. The second feature for us, which is really important, is on the Friday of Farnborough we have Futures Day. Futures Day is an opportunity we bring in somewhere between 5,000 and 7,500 young people aged between 11 and 21, hopefully to have a good time and enjoy the show, but also to engage them in a kind of structured program of activities, hopefully to persuade them that they should pursue a career in aerospace, but if not, at least to inspire them to take up some of the more challenging topics, whether in science, technology, engineering, maths, so that we start to create a pipeline of talent that is going to be interested in playing a part in some of the more exciting engineering challenges that we collectively face. So I'd like to think that Future Day is very much a collaboration. It's about the industry, ADS, my team at Farnborough, working with a range of partners to bring in people, and rather, there are lots of things that go on which are worthy activities, but actually it's when we bring a number of organisations and capabilities together that we can start to have a bigger and more impactful set of outcomes. So for us, Futures Day is about working collectively and collaboratively to ensure that we get as many people there as we can, but then deliver the best and most exciting experience for those young people, so that when they walk away with an idea about how they want to structure their lives for the future. So, thank you very much.
Now, we are now going to move on to innovating aircraft, and we are coming to the wonderful title of Electrifying the Future of Aviation. And it gives me great pleasure as a board member of Airbus Group to invite Sébastien Remy, head of Airbus Group Innovations, to speak with us. Now, Sébastien leads the Airbus Group's network of research centres. He created the Airbus Alternative Fuels Advisory Group and initiated the activities that led to the A380 flight with alternative fuel in February 2008, which was a world's first. Sébastien will talk about the Airbus Group's E-Fan demonstrator, a two-seater aircraft, fully electric and propelled by two electrically driven ducted fans. He will discuss the technical and operational experience gained with E-Fan and how they might inspire improvements in hybrid helicopter and more electric aircraft in the future. Sébastien.
Mr. Vice President, ladies and gentlemen, thank you very much for giving me this opportunity to talk about the future of aviation. And instead of talking too much about the product by themselves, what I would like to do is to talk about the future also for the people which contribute to aviation. And it's very well in line with the discussion that just took place. So electrifying the future of aviation and the future for the people working in aviation. Last year I had the big honor to be invited at the Royal Aeronautical Society President's Conference in London. And I decided to start with one slide I use at the moment, talking about the future of our industry. As you see, you recognize growth, engineering for growth. The fuel price, the safety, simplicity, competition, affordability, regulations, eco-efficiency. This is the aggregate of the competition as it is seen for our industry by the industry by itself. But I thought it would be important also to compare the view from the users. And referring to a survey that took place in 2012, when we were asking to the passengers, how do you imagine travel in that time frame? A third of them say, well, one of the most annoying things of travel is about delays and late arrival. Unfortunately, I believe that most of the people in this room have experienced that. 2/3 of the people asked say we are going to fly more by 2050, which is pretty much in line with this notion of growth that has been repeated. As Mr. President, you mentioned the double of the volume by 15 years from now. One of the most important elements that was raised by those people, almost all of them, believe that flight needs to be more environmentally sustainable. And this is perfectly in line with Horizon 2050, the Flight Path 2050, which was created in Europe, stating some very ambitious targets for the industry. I was mentioned just two here. Reduction of the carbon dioxide emission by 3/4, reduction of noise by 65% by 2050 relative to 2000. So when we are talking to the young people in the industry, when we are talking to the young people in the universities, they know that very well, and they think about what they can do in terms of improving the weights, improving the drag, improving the thermal and the propulsive efficiencies of the propulsion system, which is a very valuable way to do it. But let's think a different way to do it. Let me show you it pass. Here we are exploring how we can use electricity as a vector to improve the global vehicle. Here you see a concept of roadmap, going from the very little vehicles. The first one that you see on the bottom left, Cricri, flew about 4 years ago, 20 kilowatt. The one you just saw, 60 kilowatt, fully electric. It will be produced, certified, and delivered by the end of 2017. Again, do we want to sell thousands of them? It is not the goal. The goal is to explore what certification of fully electric vehicle means. The goal is to put them in service and accumulate in service experience. Because when we want to move up in scale, in power, maybe to hybrid helicopter, which would be partly electric, partly gas turbine, maybe to regional aircraft, maybe sometime with bigger vehicle fully electric, we will need a lot of technologies to do that. But we will need to be able to certify it. We will need a database to go in front of the Airworthiness Authority and justify that we can reliably operate those vehicles in the overall long flight envelope. Let's try to discuss what are the challenges and opportunities. But first, we are Airbus Group, but we are not blind. We just look at what others say. I've taken this slide out of a NASA presentation from January this year, where they explore the potential benefits of going from a gas turbine concept to a more electric concept. Of course, there are some penalties. The weight is one of them. But there are a lot of potential benefits. So we are not alone looking at those type of things. In terms of challenges, I would say energy storage, distribution, and power generation is a big one. We need batteries with energy density which is probably at least 3 or 4 times what we have today. fulfilling the criteria of life and security. Is it possible? Maybe. We are exploring some technology like lithium-air batteries, which in theory can be 5 to 15 times more energy dense than the current one. Of course, they are very low TRL. The interesting part of it is we are not exploring that by ourselves. We are looking to that with other partners, including the automotive industry, for instance, which are also interested in those type of devices. Electrical motor generators and power electronics targets need to be at least 15 kilowatt per kilo, including the cooling for the power electronics, to go up in the vehicle scale. Here we are discussing with people like Strathclyde University and others, as an example. High voltage electrical network and associated ancillaries. Today, for all aviation, the standard voltage is anything up to 270 volts DC. If we want to handle power in the range of 500 kilowatt, 1 megawatt and above, we need to go up in hundreds, thousands of volts, thousands of amps, and be able to exploit that. Where can we find a partnership? With the shipbuilding industry, for instance, which is already, and Rolls-Royce is contributing to that, exploiting high voltage networks. Propulsion system integration will be essential. You see on the bottom right a concept that we are exploring with our colleagues from Rolls-Royce. The principle is, if I have hybrid electric configuration, I can decouple the energy generation from the propulsive elements. The consequence is I can rethink the overall configuration of the aircraft. I can, for instance, place the fans in an area where they're going to capture boundary layer, which is good for the overall drag. But more importantly, I can use the location of those fans, the location of the gas turbine, to rethink the architectural design of the vehicle. Let me give you an example. The fin of an aircraft today is sized by the case you lose one engine during takeoff, and you have to control the asymmetrical thrust. With this type of configuration, either I lose the gas turbine, which is the center and the back. Then I power the fans with the batteries. I have a symmetrical aircraft. Or I lose one of the fans. But then the asymmetrical drag will be much lower than what we have today. As a consequence, I can rethink the concept of my vehicle to have a lower fin. As a consequence, I save weight, I save drag, etc. So this type of integrated way of thinking is vital in conducting research. It is not only developing the technology brick, but it's also thinking and taking people on board that will think differently to optimize the vehicle design around this type of technology. Certification on operations, I mentioned that. That's the key reason why we are doing the IFAN. It's a small vehicle, 600 kilo. It's flying 1 hour, a little more, 1 hour 15 minutes. But we are going to learn what certifying such vehicle means from that one. And we'll have the in-service operation to start building on database. Design and industrial maturity, same thing. The cost of the components will be paramount to be able to keep the recurring cost of the vehicles under control. And the most important part for us is how to leverage young talents. You have a lot of challenges that we have. Just imagine what you can do in rethinking the architecture of the vehicle, probably for the first time since 1950, something like that. About developing new technologies, like if I can find superconducting materials, we are working on that. We'll need to have people that understand what integration of such superconducting materials in a configuration means. Again, we can have discussions and cooperate with universities to create some research to have the people that are grown in this environment and after bring them on board to prepare the future. This is the whole purpose of the industrial roadmap that we are showing to you, is what are the technology bricks that will be needed to help us achieve those high power configuration, what are the partnerships which need to do, which needs to be in terms of SMEs, which needs to be in terms of partners in university, just like the concept of the catapult to some extent. And this is what we do already today with the IFAN 2.0. I will just mention here what the schools are doing. We have schools. École nationale des arts et métiers, the bottom left corner, which is on the test. Those guys are developing and designing the system which integrates the electrical taxiing with the landing gear of the vehicle. And the other one, which is on the bottom right, ENAC, École nationale de l'Aviation civile. This is the school which is training most of the commercial pilots in France. This school is involved with us in the configuration of the instruments, in the integration of the vehicle in the ground operation, and also for everything which is linked to training. Just imagine that if you don't pay attention, the transient of an electrical motor and the thermal engine are quite different. And they are there to help us understand how a fully electric vehicle and tomorrow a hybrid technology vehicle can emulate those transients so that the pilot can be qualified on any type of vehicles. As you see, a lot of challenges, but a lot of opportunities. So fundamentally, wouldn't you like to be part of that? Thank you.
We're now going to move to the world's largest aircraft, engineering the hybrid air vehicle. And David Stewart, who's head of flight science at Hybrid Air Vehicles, is our next speaker. And prior to joining Hybrid Air Vehicles, David worked in the aerodynamics group at Kinetic and supported the Airbus flight physics group at Filton. And he has worked on the safer long endurance aircraft as well as with Formula One teams to integrate shape optimization software into their design processes. David will talk about the largest and greenest aircraft flying in the world at present, the Airlander. It combines aerostatic lift, aerodynamic lift, and vector thrust, and has the ability to fly for 5 days at over 100 miles an hour. David will talk us through the engineering innovations that are involved in the Airlander. David.
So, good afternoon, and thank you very much, Mr. President, and for the Royal Academy of Engineering for inviting us here to talk to you about the world's largest aircraft, which is the Airlander. Oops. So, this is an Airlander. This is what we call a hybrid air vehicle. And Hybrid Air Vehicles, the company, has been around now for about 30 years or so, and we've been involved in lighter than air all that time. So this design is actually the culmination of all that experience and design iterations. The first two pictures are actually taken from the Shed 1 in Cardington in Bedfordshire. And this vehicle is the world's largest vehicle. It's 93 metres in length, it's about 26 metres in height, and its volume is about 38,500 cubic metres. As you can see, the hangar itself in Cardington is being refurbished right now, so this will be our base for future operations, and it will look quite stunning when it's fully ready. So what makes a hybrid air vehicle unique and special? So as the President said, we combine aerostatic lift, aerodynamic lift and vector thrust. To produce the aerodynamic lift, we have a multi-lobe cambered hull, and that produces about 3 times the lift of a conventional traditional airship. In the airship world, an important measure is heaviness, and that's doing the total mass, that's the mass of all the structure, the materials and the gas masses contained within the vehicle, and you subtract the displaced mass. If you get a positive number, it means the vehicle's heavy, so it wants to sink or sit on the ground. If it's negative, it wants to float away. If it's equal, neutrally buoyant. If you divide that by the displaced mass again, you get a percentage, and that's what we call the heaviness fraction. A traditional airship can take off about 8% heavy. That's what it's limited to. This design, with the aerodynamic lift, can actually lift up over 30% heavy, and we can actually land significantly lighter. So what we can do is the engines, the forward engines, can pivot and rotate just like a tilt rotor can. The rear engines have what we call thrust vectoring vanes, and that can push the thrust what way it wants to. So if we are light, if we've burnt a lot of fuel, we can push ourselves back down onto the ground and wait for ballast to come back on. So we have far more payload capability, and we have far more fuel capabilities, so we've got the endurance and the lifting capabilities. These are the two vehicles that we currently offer at Hybrid Air Vehicles. The Airlander 10 is the vehicle that was currently in the hangars in Bedford. So that vehicle was actually part of a US military program called the LEM-V program, and at the end of that program, Hybrid Air Vehicles successfully bought that vehicle back from the United States, and it is now currently sitting in our hangar. So that vehicle has flown in Lakehurst, New Jersey in 2012. The primary design point for the Airlander 10 was a long endurance vehicle. So as you can see here, we can actually fly up to 21 days with this vehicle. There's a trade-off in airships between altitude, maximum altitude you can fly at, and the payload. So if we actually want to fly a bit lower than 20,000 feet, we can actually carry up to 10,000 kilograms, 10 tons on this vehicle. So while it was primarily designed as a long endurance vehicle, it has the capability of transporting people. So we can put about 50 people in there, and we've got a very large cargo area, so it's quite happy to put 50 seats in there. The Airlander 50 is on our drawing board right now, and the design's quite advanced. That's our heavy lift vehicle. So the vehicle itself can lift about 65 tons of material, and the payload area is large enough to fit 6 20-foot ISO containers in there. And just as the Airlander 50 is primarily designed for heavy lift, it can also be used for passenger cargo. We can fit about 200 people in there, and you can also imagine you could put plenty of mission systems, computers, what have you in there for scientific work. And these vehicles, the capability is such a step change to what's currently out there. We can go to customers and say, how do you want to use these vehicles? It's a different class of vehicle. So why go back to airships? Why go back to hybrid air vehicles or what have you? So there is an emerging need for persistent airborne applications. We've seen with Google Loon, the Project Loon, the balloons in the upper atmosphere, that there is a desire to connect the rest of the world to internet, to mobile phone technology. These aircraft are particularly good at doing that type of telecommunications relay type work. With the size of the payload module and the endurance, again, for scientific climate work, you could have groups of scientists on board doing lots of work for days at a time. The endurance of these vehicles is measured in days, not in hours. There is also the need to supply remote areas. So areas that are cut off either by ports or frozen during the winter, or ice roads have to be stable enough. You can use this heavy lift vehicle to actually float and fly supplies and materials to those locations. We can also go point to point, so we can actually go from the port or an airport or a railhead to where it's needed straight away. These vehicles are able to land on any relatively flat surface, so again it's ideal for disaster relief. If you've got a runway that's been torn up or you can't get close to a runway, we can actually float onto any relatively flat surface. And combining the helium lift with our cambered hull, we're very environmentally friendly and economically sound as well. Just take you through some of the innovations that we used on, this is again the Airlander 10, this is out in America, and the hull fabric. So the hull fabric is a 3-weave, so we have Vectran for strength, we have Mylar, which keeps the gas tight, it's a gas tight membrane, and then we also have Tedlar, which is the weatherproof coating, so the white on the outside. That is incredibly strong and it doesn't stretch. So when we actually cut it and lay it down, we've got very good shape control. It actually matches what the CAD drawings said it should look like. The vehicle itself is a pressure stabilized structure, so in airship world it's a non-rigid. So there's no internal superstructure inside the vehicle. We just pump the vehicle, inflate the vehicle up, and it's just pressure stabilized structure. So the question I often get asked is it not really easy to shoot down or have a leak, or does it go shooting off? The pressure differential is 0.2 psi between internal and external. or about 1700, 1600 pascals. So if you do have a hole in the vehicle, it's a slow leak, which makes it very safe and very redundant, damage tolerant. The vehicle controls that we use fly-by-wire controls on this vehicle, and we also have multiple redundancy in our control systems. For example, if we lose one of the upper rudders, we have the thrust vectoring vanes at the back we can also use to augment control. We also have forward engines that we can use differential thrust. Likewise, we have a small bow thruster on the front of the vehicle that can change the nose point change the direction of the vehicle. The maintenance and ground handling. With our experience over the last 30 years, we know all about the difficulties of handling traditional airships. So part of this design was fundamentally to make ground operations much easier. In the past, you'd have groups of tens of people waiting for lines to grab hold of the lines and connect the vehicle to a mast. This vehicle, because of the cambered shape it has, once we drop our airspeed, we lose a lot of our lift instantly. And we also have the vector thrust, so we can drive ourselves onto the ground. At that point, we can attach ballast, and the vehicles, as you can see, this is attached to the mast, and it's only got one ground person currently watching over the vehicle at that point. Also, the vehicle is designed to make sure that the size of the vehicle requires large hangars. So all the procedures, all the maintenance can actually be done on the vehicle, so we can arrange platforms around about all the engines and about the control surfaces to make sure we can do all the maintenance actually out in the field. The landing systems that we developed. So for this Airliner 10, which was the long endurance vehicle, we have a relatively simplistic inflatable tube skid system that we call it. For our larger commercial Airliner 50 vehicle, we will use hovercraft style landing pads. So that will aid in manoeuvrability on the ground to load and offload materials, and it will again allow us to operate from any relatively flat surface. The vector thrust, as I've already talked about, the forward engines can pivot round, tilt rotor like, the rear engines and the bow thruster allows some lateral control as well at low speed. And going through in the future, we were successful in Project Locate, so that's part of TSB funding. That's a £4 million project. It's a number of areas. One of the area that I'm looking after, we're looking at CFD on the vehicle, wind tunnel testing the vehicle, and we'll also be doing full-scale propulsor tests. So we'll be building a propulsor test rig, using the vector thrust and actually understanding fully what thrust figures we get out of these engines. And as you can see, we use ducted propellers for the long endurance vehicle because that improves the propeller efficiency. And I'd just like to thank the ATI actually for the help that they produced. At the time it was UK Aerodynamics, and they helped us a great deal in putting together the Project Locate bid. And so the future plans of the company, the vehicle that you saw, the Airliner 10, will be flying in early 2015. We'll be flying under B conditions from the CAA. We expect to fly around 200 hours worth of flight tests to get the vehicle, just to understand the vehicle flight. And once we've done that, we'll release the vehicle for trials and demonstrations. And future aircraft will be fully certified under EASA regs. The Airliner 50, so the large transport vehicle, will be in service in 2018-2019 is our time frame that we're going for. Something that we are very keen on doing is actually engaging with the local schools, the local universities, getting people interested in this vehicle, because you can see from the size of it, it's quite awe-inspiring, it captures the imagination. So I've personally seen sort of surly teenagers coming into the hangar, not wanting to be there, then they see the vehicle and that's quite cool. And they want to understand they want to understand about the vehicle. So that's something that we are doing. We are reaching out to local schools. I'm going to a lot of the universities giving talks there. We're bringing some engineering placement students in this year. We'll have a formal programme in for future years to bring students back. And as we think it's a very engaging, innovative, Britain's doing large-scale aircraft again, we've set up the Airliner Club. It's a sort of a fan club So if there's anybody out there that actually wants to follow our progress or support us, please feel free to join. It's airliner.co.uk. So I thank you for listening. Hope that was within time, I think it was. And I've got my colleague here, Chris Daniels, who's head of comms. So again, we'll be outside just at the, we've got a little area set up. So any questions or you want to chat to us, please feel free to come along. Thank you very much.
So it's your chance in the audience to put questions to them, and there'll be roving microphones. Lady there. So let's move now and get the first question underway.
I want to go on the airship model again. You haven't actually demonstrated where your market is, and so I want to just give you a leader and you to say why this shouldn't be the case. This is where I think the market is, to start with, is when luxury liners started, they got an awful lot of business from very, very high upmarket clientele, and it sort of basically funded the model. So have you got a role for tying this with luxury cruises and having some sort of extra hybrid going on so you can get very, very high paying customers to go on luxury cruises and look around the look around the vistas when they actually get to locations, etc.?
I mean, you can imagine that that's a very attractive proposition. Chris Daniels, the comms director, will actually be the best person to speak to exactly on what we're planning on that. So Chris is just over there, just in the corner.
I'm interested in the electric device. Have you considered the possibility of flow batteries as a source of your power, in which the energy is stored outside the energy conversion unit in liquid form? This might be an approach which could help.
Thank you very much for the suggestion and the idea. For the EFAN, the vehicle that I have shown you, the entry into service vehicle will look basically the same. The architecture of the vehicle will be the same. So the solution, the technical solution for that one, will be with batteries, conventional battery, lithium-ion battery. The current demonstrator has lithium polymer batteries. Now, if I think in the longer term, we have an EFAN 4.0, which this one is a hybrid vehicle. It will have a range extender, a small thermal engine, which will allow the vehicle to be capable of 3 hours of flying, because as you know, the initial steps of the training of the pilot, it's 1 hour. But after, if you want to get your professional pilot license, you need to fly more than that. So beyond the EFAN 2.0, which is entry into service 1, the technology solutions are open for the EFAN 4.0 and for the future ones.
Yes, we go starboard this time.
Thank you. Kostas Soudis, professor from University of Manchester, Aerospace. I would like to make a comment on Paul's presentation. It's always refreshing to see engineers giving a presentation without the need of PowerPoint. But I would like to go back to one of your comments that you mentioned about until now we pay too much attention or too much focus on the city and financial services. I think we should be very pleased to have a strong financial centre, and London to be the strongest in the continent. But that, it doesn't prevent us of paying the same attention, the same focus on manufacturing and engineering. So we should maintain our financial strength, but at the same time pay the same attention to the manufacturing and engineering, and promote those sectors at the same time, without neglecting the finance now. Yeah. And the other comment I would like to say is about the UK within the EU, where we allow the Eurosceptics to appear on national TV and say, for instance, that it's the EU that, if we come out from the EU, will increase our exports in other markets. Again, it's not the EU that prevents us of exploring and exporting into those markets. We can do, again, both at the same time. Thank you.
Okay.
You handle the politics of this one.
Yeah, no, that's obviously I'm not an engineer, and that's why I don't have a PowerPoint. So science is a background for me, but I guess I share the view. The idea and certainly the impression that I wish to give was not that we wish to see the detriment of the financial services sector in the UK, merely that the attention is equally focused on other parts of our economy. I mean, there is a serious issue, though. We may have, the premier financial services sector globally, certainly in Europe. I speak to companies on a daily basis who don't think they get a great deal of benefit from it because they find it quite difficult to access some of that finance. So I think there is a broader change that needs to happen. I think politically there's an understanding, but if you like, the idea of patient capital is not one that is particularly embraced, let's say, within some institutions within the city, but it is patient capital that many smaller businesses require if they are to access some of the opportunities that we believe are there. So, I think the building a stronger relationship and understanding between manufacturing, engineering and the city is actually quite important. Because without proper understanding, we don't get the finance that we actually need. And I totally agree with the issues that you mentioned about the European Union. I mean, for us, it's not just as a source of kind of exports or as markets, but it's actually the power of being part of the EU gives us in some of the bilateral trade negotiations that we will need to have if we're to create a more sustainable global market longer term.
I think, too, that if you go back a little bit to 08, 09, there was a realization that financial services would not provide the growth that was earlier anticipated. And without doubt, we need a strong financial sector. We also need a disciplined one. So, secondly, I think there was the realization that North Sea oil and gas was declining. So where were we going to get the alternative growth in the economy? And designing and making things isn't a bad place to start. So I think that what the industrial strategy is actually an absolute need for the country. And I think it was the Chancellor himself who recently, on commenting on the growth figures, said we're not necessarily yet getting the right type of growth. And in other words, sustainable growth of this type rather than just consumerism is a critical for the country. And that's what our business is about. We can take one more quick question before tea. Yes, sir.
It's Bill McGawley from TDR Group. I'm picking up on Paul's enthusiastic presentation and the very seductive figures that are given about the potential market growth over the next 20 years. But I did note that he said we need to protect what we've got and also position ourselves for the future. I noted this week that Jaguar Land Rover, who are just producing the first Evokes in China, are quite concerned that there's already a lookalike vehicle now being produced in direct competition. So I think we should be very careful about getting too juiced up about the huge size of the market, because we face quite significant competition from that sector of the globe to usurp our world leading current position.
But I think the nature of the strategy, and I agree, is that we can't afford to be complacent. I think that's the message that certainly I'm enthusiastic, but the protect and position is about ensuring that we don't underestimate the competition. The reality is, if you want to do business, if you want to sell aircraft in China or India or in some of these other places, there is going to be a level of industrial activity that you are going to have to do there. And Airbus are and others are and others will. The challenge for us is to ensure that what we might see as the newest, the best, that which adds the greatest value, is kept closest to home. And we can only do that if we're focusing our attention and resources in the right place.
I think at the end of the day, you never can get away from competitiveness in a global world. And the very topic of this seminar, innovation, is an absolute key to competitiveness. And that plus the productivity of our manufacturing systems and the efficiency of our supply chain. Yeah. So the only way you can protect your market at the end of the day is to be highly innovative and highly competitive. Because I've just come from China overnight, and I was at a huge engineering seminar there, and there is absolutely no question that we will be facing huge competition on the very front of innovation and technological leadership. So you can't be King Canute and keep it back. What you can be is develop leading edge, be the best. Thank you very much, and thanks. Let's show appreciation for our three speakers.